All right, awesome. If you guys could tell us a little bit, professors, about your research area, just a little bit more detail. I know you already kind of went into it, but what is it all about? What do you guys really do?
You want to go first? Go on.
Yes, that's fine.
I'll start eating. You guys don't mind, right? This is supposed to be a lunch, correct? Okay.
Yeah, that's fine.
Okay. Should I go first? I think there's a misunderstanding.
Yeah, I think
Kwan, do you want to go first, or should I?
Oh, no, I thought you'd go first, though.
No, I said that. Do you want to go first? But yeah, up to you.
Please go ahead.
Okay.
Yeah.
Okay. So okay, I'll talk about causal influence, I guess, a little bit. It can be described within the context of machine learning, but it's a bit more general than that. So let's say you have a system, right? And you don't fully understand the system. This can be human body, this can be some man-made object, but you don't have access to how it really works, right? You don't know the physical mechanisms that realize the machine. So then you can collect data from this, right? So the machine learning approach would be, let's say I collect data, and then I use this data to come up with some sort of probabilistic model, right? So if you have taken basic probability theory, which I'm teaching this semester actually, then you can collect a bunch of samples, and then from the samples you can estimate the probability distribution. And if a state, let's say your machine has a bunch of states, right? Then you can say things like, okay, if a state takes this value, then it's very likely that this other state will take this other value, right? And then you can do prediction based on that given features. That's all good until it's not. So the point is that the probability theory will only take you to a point. Oh, we are also recording, huh? Okay, good to know. The probability theory will take you up to a point only. So what I mean by that is that, okay, if the system works as it's working without any outside intervention, right? Without any changes, let's say the outer temperature is always around 20 Celsius, right? If things remain stable and things don't change too much, and the machine operates in the same way it was operating when you collected the data, then everything is fine. But the problem is that things might change, right? Or more importantly, you might try to change things in the machine itself, right? Let's say you have a knob on the machine, right? And this knob can be changed to affect a specific variable in the machine, right? You can also read the value corresponding to different variables. Now, if you want to understand what happens when you change the knob, right? When you rotate the knob and set the value of the variable to a certain thing versus when it was something else before, right? The samples and the distribution that you modeled will be useless to you. I mean, not useless, but will not really tell you what's going to happen, right? Because when you switch the knob, you are actually affecting how the machine operates. You are forcing a certain value on a certain variable, but before it was just governed by intrinsic mechanisms that, let's say, you don't know, right? Causality comes into play here. If you actually have a causal understanding, if you actually understand the causal mechanisms within your machine, then you can model how the machine will react to your input. You turning that knob and setting it to a specific value, you can actually model how it's going to react, right? So that's why you need to go beyond the probability distributions. You need a causal model to understand what's going to be the effect of your action or effect of your intervention, right? So my research focuses on specifically this goal. You have a system and you don't know the system very well, but you have data, right? You have some sort of data. How much causal knowledge you can extract from this data about the physical workings of the machine, of the system, and use different tools like, of course, probability theory comes into play, graphical models comes into play, and information theory, graph theory. You can use all kinds of tools, and it's a lot of fun. So that's the motivation of why I do what I do, and snapshot of the real world impact, if you want to call it that.
That's some
Feel free
really,
to ask more questions if you're interested, and I can try to elaborate on.
you know, that sounds like some really neat stuff, way beyond me, certainly, but very cool.
Thank you.
Oh, yeah, that sounds fascinating.
I don't know if you can see chat, but Jared just asked if there are any what industries that can be applied to.
Yeah, so causality, you can answer that question, right? Think about it. Think about what I just described. Where is this relevant, right? Or maybe think about where is this not relevant. It's very hard to come up with an answer like, I don't know where this is not relevant, right? So this is relevant everywhere. If you have, let's say you provide some sort of service, you have customers, right? And then you want to understand what's going to happen when you change something about your product. That is causality. You need to understand how people will react to your change. And for that, you cannot just use probability distributions, not all the time at least. Sometimes maybe you can, but in general, you will need to model how such an action will change things in your system, right? Or your machine learning models. This is an ongoing research area, and what I'm about to say is quite vague, and people are trying to formalize this currently, but machine learning systems, you train them, you deploy them, right? But then certain things may change in the environment. So the changes in the environment can be modeled causally, should be modeled causally. And then maybe your system should take this into account, right? So it's hard to imagine where this is not applicable, right? But personally, what I do is more on the theoretical side, right? So I don't really go after, oh, where can I apply this? Where can I apply this? I go after more about algorithmic developments, right? Under specific assumptions, show what can you recover about the causal structure, and maybe show that this is complete, you can't do better than that, and make sure that your algorithms are efficient, being polynomial time, or maybe some small number of samples. So these kind of things are what I'm more concerned about. Hope that answers your question.
So just to ask a clarifying question, this is for like very, very complex systems where it's very difficult to see from the outside what might cause what. This sort of research would allow the user or like whoever's working with this system to understand the system on a deeper level.
Yeah, exactly. Yes, perfect. Yes, that's very good. If you have like two variables and you know like one of them is the cause by side information, of course, then you don't need more than that. You are still using causality, right? But you are using it because it's just very simple to infer. But yes, if you have like 1 million variables or 100 variables even, right, it's very hard to understand what's going on with side information. So can you automate that process a little bit, at least? Right.
And I do believe that answered Jared's question. Yes, he says thank you. I do believe then, Professor Kim, would you like to talk about your side of things?
Oh, right. So I've been working several different projects right now, but as some concrete example, something I did just like this past quarter was to study the end-to-end TCP, Transport Control Protocol performance over 5G millimeter wave. So in this particular study, what we did was that we look at this question. In 5G millimeter wave, you got a really good RF, and you also really good the physical layer. So the question is, can the TCP congestion control protocols actually catch up and be a friendly transport layer in order to work with some unique characteristic of the physical layer represented by the 5G deployment? As I said when I introduced myself at the beginning, I have a very realistic and configurable the test bed in my lab. So we have been able to carry out very extensive studies for this one. So we asked several questions, like for example, we ask what would the existing TCP congestion control protocol actually performs over the commercial 5G network. So there are different types of a TCP algorithm, like a loss-based and delay-based or rate-based congestion control algorithm. So we compare about 10 different TCP algorithm over the 5G network and how they actually perform in 5G throughput as well as round trip time. That was one of the questions we asked. So the part of the answer that we got is that the rate-based congestion control works actually particularly well with a kind of latency and then throughput characteristic in the physical layer represented by 5G millimeter wave, and also some kind of hybrid version also works quite well. So we identify some of them. And the other question that we asked was, we know that the millimeter wave, this is a 28 gigahertz frequency band. So they typically suffer often from the line of sight. So there has been a lot of physical layer measurement and some mitigation work on this, on these kinds of the millimeter wave link. So we ask this kind of question, this is cross-layer question. So what would happen at the TCP transport layer throughput end-to-end perspective when you have certain kinds of a physical layer blockage between the radio, between the RF antenna and the device? So there are some interesting answers for that as well. And the other one is that we also look at some particular application web browsing and look at the page loading time comparison. Of course, there are some different web browsing scenarios. So actually, this is exactly what users actually experience when they actually use the 5G network. So we look at some application layer performance. It's a layer 7, even over a transport layer. And so one of the answer that we got is that actually the bottleneck is not about the transport layer. Actually, we got, when we look at the transport layer, we got really good the low latency performance. But when we actually measure the page loading time in the application layer, the latency reduction that we would expect from the transport layer has not been observed in the application layer. So actually bottleneck was more about in the application side. So, but I think as time goes by, maybe application layer performs better, then probably we'll be able to experience much better over the 5G commercial networks though. And the other one is that this is another application, but here we have the deep neural net learning computation uploading scenario where you actually want to upload some heavy computation load from your device to either the edge server or the cloud server. And then the reason why we want to do this is that your 5G phone or maybe your other phone have a less capability to perform machine learning. So you want to actually upload your computation to the closed edge server or the cloud server so that they can do some work for your device. So we also measure the query time and how the 5G network actually performs well in this case. So yeah, those are the questions that we actually asked the past quarter.
Wow. Okay. Now, I'm curious. When you talked about measuring like application load time or website load times, and how do you actually measure that? Because it seems like there's a lot of things that could like slightly change in a lot of different ways that would affect the load time besides what you're trying to measure.
Right. So that is why we have our own 5S test bed. So this is the separate test bed, independent of the commercial one. So in the commercial one, there are many different environment, conditions. I mean, some people might close to your radio base station, so they might be able to download the video quite a bit. Then that might affect your experimentation. So so we don't want to have that kinds of additional component. So we want to have a control environment. So we have a control environment. So no one was there except us. So we can actually conduct our experimentation in control setting. And also as to the like application loading time comparisons, right? So we can actually control the background application. Like if sometimes so depending on what application is running in the background, like, so it's possible that you want to stream some live TV or something like that. So how that affects the page loading. So we can control all different things on the device as well as the RAN side. So that is how we actually measure the latency and query time or throughput as well.
Okay, that makes sense. Yeah. That's neat. Not seeing any questions from other students, so follow-up, I suppose. How can students participate in this sort of research area? Maybe not for even beyond you two specifically, like just how do they get into the research area in general? Maybe what sort of classes should they take, that sort of thing.
Right. So I think that taking classes seems to be the beginning step, because you actually, in order to get into this kind of research or some industrial experience, you need some basic knowledge about communications, right? So probably you might want to take like digital communication or some wireless communication coursework that would equip you with some necessary knowledge. Right. So, and also, I think there will be many opportunities in the internship, like in industry, and that also will help you to get some experience in wireless communications.
Right, and I believe that was Professor Gamal that just joined. Is that correct?
Yes. Hi, Andrew. How are you?
Hello, I am quite well. How are you?
I'm doing well. What year are you?
I am a junior in electrical engineering.
Okay, that's cool. Are you taking 301 and 302 right now?
I took 301 last semester and I'm taking 302 now.
Okay, that's cool.
Ben and Jared, if you would like to introduce yourselves again real quick.
Yep, my name is Jared. I am a sophomore in electrical engineering. I'm sort of here to get more information about a bunch of different research areas, and this is the last research area that I have to go to. So I'm interested in learning more.
Ben, you still with us?
Sorry, I had to go AFK for a moment. I'm back though.
Could you introduce yourself again for Professor Gamal?
Oh yeah, sorry. So I'm Ben. I'm a freshman here at Purdue, looking to go into ECE starting next semester. So yeah,
Nice to meet you.
nice to meet you as well.
All right, well, The other professors have already covered this, but you should as well. Can you talk a little bit about your research in the area?
So I'm doing work primarily in machine learning applications and wireless communications. But I also happen to work in machine learning for other things as well. And one exciting thing is we have this autonomous race going on, something called the Indy Autonomous Challenge. In October, there will be an autonomous race in the Indy Motor Speedway. And we are basically working on programming the racing cars to compete in this. And there will be a simulation race in May in concurrence with the Indy 500 events. By simulation race, I mean in a simulated environment, in a simulator. Yeah. So that's a cool thing. I also do some work on machine learning for agriculture. And I do work on theoretical side of learning, kind of similar to what Murat probably said, but a little bit different work on basically trying to find a theoretical framework for learning in general, for machine learning. And before, and I'm still doing that, I've been working on like theoretical side of wireless communication, something called information theory, and basically it started out as a theory for communication systems, and I was working on that aspect of it.
Okay, that's very neat. It sounds like there, well, I mean, I suppose I'd expect some overlap in everyone being in the same broad research area of ECE. We
Yeah.
were just talking about how students can participate in this research and what sort of classes they might want to take and things like that, if you have any insight.
So I guess for the three of us that are here, the 301 and 302 are important, which are basically the signals and systems and probability. And I feel like that's a step transition that happens to you after 301 and 302 and before 301 and 302. And the programming classes also are very important. 368 is I feel like a course that makes a difference to the data structures. Yeah, and then at 400, like it's up to you, like the research area, like it's more advanced classes, but yeah, the 300 level courses are a milestone, some of them.
Yeah, no, that's been my experience as well. 301 and 302, it's so different from the stuff I've done before it in EE. But the most important thing I think I've learned is that I don't have the right sort of mindset for this sort of thing professionally, but it is still really cool.
Yeah, so I guess these classes you can get lost in the details, and then at the end you don't know what happened, right? So it's good to sit back and figure out what was the like few concepts. Because these two courses are a little tricky. Like probability is a concept that's very weird at first, and it takes a while, I feel, to digest it. And also the stuff with signals like Fourier transform and these things, it can feel like science fiction at the start.
So if you want to do research, right, I would, as an undergraduate student, of course, if you want to do research, I would recommend first find the person, right, and read some of their papers, okay, and then try to think of extensions, like what can be done as a next step, and then reach out to that person only after that, right? When you have some idea, it can be stupid, it can be a stupid idea, just some brainstorming at least, right? So show some effort before, and then reach out to them, and then see if they have time to do research with you, right? So multiple things should align for this, but I would say that's the right order of things. If you just ask someone, oh, I want to do research, I don't know what I want to do, just give me something, that's unlikely to happen. Most likely they won't have time. But if you can somehow get their attention and then show some promise and creativity and also technical background classes, as mentioned before, right, you need to take those courses, of course, but after that you need to show enthusiasm and some promise. Basically, that's how I would do it. I would recommend you do it.
So with
And-
those, Jared just
Yeah.
sent a question in chat.
I was gonna say also look for serve opportunities. That could be a good start. Like sometimes professors have like these projects posted for serve, and then if you're in, like, they are interviewing undergrads to do it in the summer, and the reason is that it's easy for the professors because the department and the school, they pay like a big portion of it. So actually, that's how I got introduced to many very good undergrads. So
Okay. And Jared had just asked, what is there a good spot online to find published research?
the person's website. Yeah, I mean, first find the person and then look at their website and you will see papers, right?
So with how important like 301 and like those 300 level courses are for your fields, is there any way that a student can really get involved in that research without having taken those courses? Or kind of like preparing themselves before it sort of thing, or?
I feel like the programming stuff are doable. But
Sure, yeah.
yeah. So if it's just a programming project and you have taken you know like enough of Python, TensorFlow, these things, that's doable. But some things are like some things need background, like wireless communications, for example. So you would need to know signals and systems and know a little bit about wireless, and yeah. I guess Kwan can say a little bit about that as well.
No, I already shared it. I think that those are the prerequisite for research.
Yeah, there are
Yeah.
quite a few. Oh, sorry, go ahead.
No, yeah, I'm just gonna repeat. You can do coding, but it's not really research by itself, right? Coding part. What you can do, I think what Ali is saying is that if there's an ongoing project and if there is some need for someone to code something up, perform an experiment, it could be mutually beneficial in the sense that you help them, providing your expertise in terms of coding and your time and effort, right? And that's useful. But for you, the advantage is that you will get to be exposed to the inside of a research paper, maybe a research project at least, and then learn more about the other parts of the said paper, right? And then get a better understanding of how the research goes. Then that could be your starting point to get in touch with that professor and then take on, once you have the necessary background. Yeah, like for me, I can't think of anyone being able to do anything without knowing probability theory. Right, so I can't imagine without 302, I don't think. Like, you don't have to take the course, but you need to know probability theory. So that's it. That's that.
I suppose more anecdotally, I do remember, might have been a month ago now, I remember seeing in the weekly newsletter that gets out to students. I don't remember which professor it was, but there was a professor looking for someone specifically to program an Android application. And that was all they really needed them to do. So that sort of thing, it sounds like.
Yeah.
Yeah, it's part of something bigger, right? Otherwise, it's not a research project; it's a coding project.
Mm-hmm.
So I don't know what to call what, but yeah, yeah.
That's kind of been what I've seen in a few different research areas. Actually, is that you especially like I've been looking into semiconductor stuff because that's my main interest, and that's another area where you absolutely have to have like a baseline level of knowledge before you can really get going with it. I've been looking into, of course, various career options, and most of them will require some sort of a master's degree to work with semiconductor fabrication. And that's just kind of a parallel to what you guys are doing. It sounds like a base level knowledge kind of thing.
That's right. Even the experimental stuff, like I imagine in semiconductors, there's a lot of experimental work. It like you need to get exposure a little bit to. Yeah. So basically, any way, I think that's what Murat was saying. Any way to be, even if you don't have the prerequisites, and there is an opportunity to be exposed to a lab, that's good.
I had a quick question.
Yeah, I mean, there's
Oh, sorry. Go ahead.
like very quickly, there is like a culture, right? So in each research field, there's a culture. If you try to sit down and read a paper, right, most likely you're not going to understand it because you don't know the culture. Like when they are not going to explain everything, starting from undergraduate level and then building up hundreds of years of research and on top. But there is a culture. There is some when somebody says something, you understand what they mean. It's not all self-contained as much as we pretend it to be, right? It's self-contained given the culture of the field. So you need to be exposed to that before you can actually do research yourself. Like even reading papers, I think that's a great thing. If you can read papers, that is amazing. That's actually how I learned most of the things I'm doing today. Not the courses, given the undergraduate and graduate courses, of course, but not the courses. The papers teach you a lot if you can read that. Yeah, so getting any kind of exposure to that culture somehow, and that should be through some faculty who is actually doing that, and then spending time with them and with their lab. Yeah.
So I was going to ask for everyone, what, like, why did you choose to go into this field, and what like pushed you towards this sort of research or these topics?
That's a tough question. So I like, to be honest with you, it depends on your background, right? I'm from Egypt, for example, and like success in Egypt is either engineering or medicine. So like that's the that's the social norm. Here in the US, there are more things. Like people can be considered successful doing more things. So I was choosing between engineering and medicine basically, and I chose engineering, and then the computer engineering. So my undergrad was computer. Sound like the most cool things because I like to put on these motherboards and burn stuff and stuff like that. And then later I got, like it happened gradually. Then I started to like science after like in the masters, but before I didn't know like it was not that intentional, I think. Like there's a lot of external circumstances that pushes you, but you try to make the best out of them. The I feel like the best part where I started to like science was grad school. um, and yeah, I was in Urbana. It's similar to Lafayette. Like there is not much to do. You just focus on what you're doing, and yeah, I guess now I can see why someone would want to do all this from the start, but I didn't um, when I did it. I don't know if that makes sense to you.
No, that makes sense. Thank you.
Do you want to answer or no?
Yeah, that would be cool. I'm curious. You guys can answer that same question.
It's definitely a big question.
For sure.
Might take a second to think.
So E169 has joined. Oh, that Edmund.
Oh, would you like to go ahead and
I think
introduce
we're again
yourself?
waiting for
Oh,
each other.
sorry, go ahead.
Karan, do you want to go?
So I think for me actually, so when I went to the high school, like specialized in science and math. So I actually enjoy the like element of discovery in science, and also I really like solving some challenging math problems. So and how math and science can explain the natural world. Right. So when choosing my college major, I actually wanted something like that would involve scientific exploration and discovery, and provide some meaningful contribution to people's lives through technology. So I saw the ECE, electrical and computer engineering, as the most suitable way for me to apply math and science in a way that had the most significant impact on society, and also quenched my thirst for discovery. Short answer.
Makes a lot of sense. Thank you.
Should I go or should we ask Edmund to introduce?
Why don't you go or Edmund just unmuted himself. Go ahead.
Hi, everyone. I'm Edmund, and I'm a sophomore in electrical engineering.
Is there a specific area of electrical engineering that you're most interested in?
I'm not completely sure. I have to explore like the different fields of electrical engineering first, but I'd say like the first one that maybe piques my interest is, I'd say, like maybe like the energy grid and power systems and all of that. But we'll see.
Okay, yeah, I mean, how did you choose this field or something like that, right, was the question. I mean, my story is similar to Ali's. It's very rare people know what they will end up with eventually. You don't plan this in high school and, oh, I will be a researcher doing causal influence when I'm 33, right? You don't do that. So, I mean, for me, I was interested in electrical, playing around with electrical circuits and stuff before college. So that played some role, but also that the department is very prestigious in Turkey as well, like in Egypt. So those played a role. But after that, you start research and then you start to like other things. I think it's just important to like be open, like don't say I will do this forever and ever. That's never gonna work out, very rarely. So just be open, be flexible, and try different things. After I came to the US for PhD, of course, my research topic is shaped by my advisor's interests, right? So that's just the reality. But I had a lot of flexibility from him as well. So I made the choice of doing this. And for me, the reasoning was, it is a very fundamental topic, and it is something that is not exhaustively researched on yet. So there's a lot of room where I can make a contribution. That's also important. I think like where you can assess your abilities relative to what has been done, what has been tried so far. I did work on learning theory, but that was just too much worked on, and it's very hard to carve a space for yourself in that, right? So yeah, I mean, many things affect. Just keep an open mind and try different things. That's what I would say.
All right, and I am gonna have to break in again real quick. I am sending that attendance link in chat for anyone who joined midway through. The SAO just requires us to use that to track attendance. It'll prompt you to log into BoilerLink with your Purdue account.
So typically, like I think that undergraduate students probably will have some hard experience to read a paper as they are, because it's very heavy, like math heavy, or you actually require a certain background knowledge. So one easier way that I think it might work for undergraduate is that there are actually many, like several IEEE magazines where actually you can find some articles that are easier for readers. They explain it like using some label language, not the just real paper. So like there are many magazines, Communication of the ACM or IEEE Communication Magazine, and IEEE Comstock Technology News, and IEEE Signal Processing Magazine, and IEEE Spectrum. And so I think those kinds of magazine you might find interesting and also help you be exposed to the area like communication, machine learning, and so on.
Yeah, that's right. I totally agree.
That's very helpful. Those papers do tend to be very daunting.
I have just had a thought actually. So I didn't mention this in my introduction, but I'm minoring in material science and history because I thought history is fun, and material science I thought complemented semiconductors well. Are there any like other, I don't know what the exact word I'm looking for is, but there are any other areas that students could look into, like for a minor or a double major or something, that would complement your area well?
Computer science is an obvious close thing. But I'm not sure, because maybe you can get all the stuff you want in CE. But sometimes they have courses that we don't have so far. Yeah. Yeah, like database, for example. Like it depends on what you want to do, but sometimes they have these tracks that that we don't have yet. But yeah.
Yet being the operative word, I suppose.
Yeah.
I mean, I don't know. It depends, but in general, I probably wouldn't spread myself too thin as well. If you try to do everything, you will end up doing nothing, essentially. Try to make the best of your courses and the professors in your department or in the department you're interested in, and focusing on that. If you want research, if you want a job, then again, it depends. I guess material science is nice. I guess for you, it's actually a very logical choice, right? If you want solid state stuff.
Yeah.
Yeah, that makes sense. So like when you do things like that, you can be among a pool of, let's say, 100 candidates for a single position in a lab. You will be unique in the sense that you bring a combination of two expertise, right? So that's actually a good thing. But again, don't spread yourself too thin, I would say. I did have a minor in undergrad, but like, so the point is, I don't think anybody cares if you have a minor, majors, double major. It's what you can bring on the table. It's like, title is something, but if you force yourself to just get the title and be done with it for the sake of it, I don't think that is just too good. So take courses you like, take courses you think will matter. Then that's it, I think. Yeah.
Also,
So you guys have a lot of flexibility in the US. We didn't have, like, I couldn't take history courses just like that. I had to take a few, like forcefully. I had to like make it count. It wasn't allowed. So you guys have a lot of flexibility. So maybe I'm a little biased while I say that. So also take it with a grain of salt, right? Sorry, Ari, go ahead.
I was gonna say there are some, like for example, if you want to work in autonomous systems like self-driving cars and these things, mechanical is an obvious thing, that it's obvious that you will need the courses from mechanical engineering. And like something like intelligent transportation systems, it's obvious that you will need stuff in civil engineering. So there are these emerging areas that are actually naturally at the intersection of us and someone else. Also, like there are things that are like, there is a need, I feel, in the country in general, in people that understand technology and at the same time understand the humanitarian aspects in politics and so on. So so that probably will, you can reach out further, like to things like political science and philosophy. uh, like there is a topic called ethics in AI that naturally needs someone with expertise in computer engineering and philosophy, or sociology or something like that. Yeah.
And that,
There are many topics, many emerging areas that need that you take to, at least.
I suppose that kind of leads into one of the questions I always like to ask when we do these lunches is things like what people call soft skills, like communication, writing, political science, stuff like that, and how important you guys think that it is for your field, or even for just you personally, professionally or academically, or just in general.
I think it makes a big difference, but it does differ significantly between the industry and academia. So there is an aspect that we wouldn't know that much, especially if we don't have a long experience working in a company, like how to basically climb up in a company, right? But actually in academia, that's a big aspect. Like when you teach, like you're not trained to do that before. Like it's not just that you know the technical stuff. There is a lot of aspects about not just teaching, even when you manage a lab, about basically understanding people, because these people will make a big difference in the output of your work. You will be judged on how you interacted with them. So so that's a big aspect. I personally learned it just by experience, but like I'm sure if you study it rigorously, you will be faster and better.
Yeah, I mean it's an open-ended question. I don't know how to answer it, but I'll summarize. Well, I think me also, like, we learn it as we go, right? As you need those skills, so it's hard to say what I learned along the way. But communication skills is definitely very important. Like, you can't explain your research in both academia and industry. You can't explain your research. So for us, it was a different challenge, right? Like we had to learn doing our daily things in English, in a separate language that we didn't grow up with. So for you guys, it's a little easier, I would say, right? But other than that, maybe having some sort of empathy is important. Just like, don't be a toxic person, right? Like usual things I will say. I mean, you're laughing, but these things are creating issues in academia today. As far as I can see, you can follow, if you follow on Twitter, what people are going through and stuff like that. Just, it's important to not leave human side behind and just focus on technical work. But I don't know how this helps you. But yeah, this is my opinion.
I personally strongly feel that the communication skill seems to be very important in both academia as well as industry. Right. So like communicating what you want and how you want to carry out, how you want to collaborate with others is really important. Like sometimes when you collaborate with some people, you might get into some conflict situation, and then you might want to resolve that conflict And so how you communicate with that person or some other group would be very important. So I think, yeah, I feel like the teaming and communication skill, I mean, those skills are really, really valuable, I think, for research. And yeah.
Well, thank you for your insight. Yeah, I hadn't considered what's the phrase I'm looking for? You mentioned how people can be kind of toxic in some environments. I actually hadn't realized that. That's interesting.
Really? Okay.
Well,
Yeah.
I guess suppose I've been lucky. I've just never encountered any of those people.
Okay. No, I
part of
mean,
it,
me neither personally, but you can follow stories of what people have been going through. Like, for example, you can easily pick a PhD advisor, right? And you think they look great on paper, and that's amazing. But then you read all these stories about how abusive they were and how they made life hell for their students, right? So these people exist. We can't pretend they don't. So that's all I'm saying.
Yeah, part of it might be that I know you mentioned Twitter, and I don't actually have a Twitter account, so that might be part of why I haven't seen it.
That's probably a wise choice, but yeah. Right.
I have a question, if that's okay.
Yeah.
So how have you, or how would you continue your education past formal schooling? So for example, when I've graduated, how would you recommend that someone like me, or how have you yourself learned more about the fields that you are interested in? Because obviously we can't take every single course in ECE, even if we're interested in them. I know, Andrew, you said in our last meeting that you wanted to take this course, but you, in that sequence, you would not be able to graduate in 4 years. So how would you continue that education, even if you can't take those formal courses in university?
Do you mean like other than master's or PhD? That's the natural sequence of things, no?
I suppose after, or suppose besides a master's or a PhD.
Yeah, so actually part of that, the answer to this question is that things are changing. So so just follow what's gonna happen, because I feel like at least just from following like the school's website and so on, that there is a lot of discussion on how education will be going forward, especially after the COVID experience, and incorporating the remote stuff with the in-person, and will there be things offered to people that in the industry and so on. So there may be opportunities available to you that were not available to us. So that's part of the answer. Yeah, I guess so basically that's the short answer, that there will be. And also there is a lot of material available online that was not available at my time, for example. So I feel like you can use that a lot. Like you can easily learn something new by just looking up the resources online. Resources, not just tutorials, but maybe you find complete courses or like textbooks that are free online. So yeah.
I mean, I go ahead.
No, go ahead. Yeah, I will follow.
Okay. I mean, I kind of, it depends on the person, for example, right? I wouldn't think myself as, I don't think I would be successful doing that. But again, it depends on the person. If you have a lot of self-motivation, then it's great, but that's something very rare to see, right? Typically, shooting for a degree is what motivates you to take courses, to actually put an effort to do the homeworks. Even if you are just taking a course for like, not taking it, but just sitting in, right? You are inclined to not do the homeworks or just cut corners because you have other things to do. When you start a job in industry, it will be the same. you will have things to do. So then on the side, you take some course online, but like it's not that important. So you can cut corners. I don't think it's going to be the same as, for example, doing a master's degree or PhD degree. But yeah, that's my opinion. Maybe you have a lot of willpower to actually do all that. So that's great, but I don't think I would be able to.
So I think it, I just want to add on top of that. So I think in industry, it depending on companies, but like big company typically has some coursework available to the employee. So if you want to increase your skill level, or if you want to learn something new, then there is a, there will be an opportunity to take it. And also, as Professor Algamar said, there are I think there are many online materials available on the web, and also there are online classes in edX or Coursera. So I think if you are really motivated to learn something new, I think there are many opportunities you can take.
And there are even like now, for example, I have a student in my group who works in a company, and that's a relatively new thing in the US. Europe used to be like that for a long time. But this is relatively new here, that universities are open to that option, that someone is concurrently doing a PhD and working.
Yeah, I think I remember hearing something about a program like that. I don't remember if it was Purdue or another university, but yeah, that was an interesting idea.
Yeah, I think we have stuff, but I'm not an expert. So yeah, but I think there are new programs here as well that enables these options.
I do agree, though. I think the big message there was that like motivation is kind of at the core of it, and I'm definitely one of the people who also would not be able to self-motivate to do an online course like that on my own. So I think something like a concurrent program, I think that could be really good. Looks like we have about 20 minutes. So unless we have any more student questions, I would like to kind of flip things around real quick and see if you guys have any questions for students that we might be able to answer.
Yeah, so I mean, I am new here, right? So it would be good to hear some insight on the student side. How do you feel about the school in general? Do you have complaints? I mean, unfortunately, you are recording this, so nobody will be able to say frankly, but as much as you can, it would be nice to hear the insights. Maybe what is not feeling right, what could be improved, just to get some feedback.
I could pause the recording for a little bit if you'd like.
It's up to you. I am listening, so.
I will go ahead and pause that for a moment. All right, yeah, so about 4 minutes if anyone has closing remarks. And if we don't have closing remarks, then I can talk for 4 minutes.
Is that a threat? That sounds like a threat.
I think this was a good discussion. A lot of information going both ways. Thank you all for being here. This is, I know schedules are busy nowadays with everything being so everywhere.
Yeah. I mean, closing remarks, I would just say communication is the key. Try to reach out to the people who has the power to solve your problems potentially, right? Reach out to them in a nice manner. Don't be shy. Send lots of emails around. Go knock on their door after COVID, not before COVID, after COVID. Yeah, like initiate conversations. That's all. Like this is college, right? It's not high school, so you should be able to initiate conversations when you need something.
Yeah, and I can kind of attest to that, I suppose is the right phrasing, where I have never emailed a professor and had them go why are you talking to me, or something along those lines. They've always been pretty welcoming to somebody reaching out to them.
Yeah. I mean, if they are a professor, most likely they are a professor because they like teaching, they like interacting with students, they like sharing their knowledge or wisdom, right? So yeah, let's just assume that as a given and go with that.
All right, well, thank you all again for being here. It was a nice hour and a half. I hope you enjoyed your Uber Eats lunches. I believe it was Uber Eats.
Yeah, I didn't get that, but yeah, I had breakfast. Thank you. Yeah, this was fun. Thanks for the invitation.
Of course.
Yeah.
Yeah.
Thanks a lot. Yeah.
Thanks a lot. Yeah.